822 News Radio, WJPF. I'm out of my league. I'm out of my depth is what's happening. I'm joined in the studio by Bob Baer and Mike Kintrinakis. I've sort of struggled with what exactly to call you guys all day. Stargazers, astronomers, scientists, researchers. Bob, we'll start with you. What sort of alphabet soup comes behind your name?
Oh, gosh. So, yeah, I co-lead the total solar eclipse planning at SIU Carbondale. And I am a specialist in the School of Physics and Applied Physics. I do astronomy, public astronomy outreach, some research, and some instructional support over there.
All right, we're also joined in the studio by Mike Kintrinakis, amateur videographer, it looks like. And Mike, what about you? What would you call yourself? What's your specialty in life?
Well, I guess I could say I'm an eclipse enthusiast. I'm an amateur astronomer. Astrophotographer, and just a general advocate of sciences and such. I've been active in astronomy since 7 years old, and then became very active at 14 when I got to see my very first total solar eclipse on an expedition with New York City's Hayden Planetarium and the Vanderbilt Planetarium, going to Winnipeg, Manitoba.
Wow.
And since then, I'm losing count. I think it's 14 total solar eclipses since then.
Does the awe of it ever go away? You know what to expect?
No. Each one is different and individual.
Really?
Absolutely.
What are some of the small differences that you can tell?
It's a combination of the ambience of the locale where you're at, the time of day, who you're with, what you're feeling like, your emotions, your feelings, the weather at the time, the coronal structure, what you're seeing, the chromosphere structure of the prominences and spicules and such that are emanating from the side of the sun that you're able to see with the naked eye, which is a hydrogen alpha wavelength. And we have these specialized telescopes that we're going to use on Saturday to see that, but can't see it with your eye because the sun is so brilliant. It just masks it out, though it is there if you could see it with your eye. But yes, each one just has a completely different configuration. There's a duration, there's timing. For instance, the difference that you're going to get here from 2 minutes and 38 seconds to I think it's close to 4 minutes here. I think is that
4 minutes.
4 minutes. So you will, I'm not going to say twice the darkness, but much darker, much longer, deeply mysterious, and you I don't want to say does this ever stop? But it's a long time.
It's going to say,
because
what's going on here?
Where every second counts, where it's so much. It's not so fast because you're so enthralled in the moment. You're taken by every second, and now it's going on, and it's not really going on until it's over. But that 5 minutes can be like a long time.
Oh, I bet.
Which people won't say it that way. It's the fastest thing. It's not long enough, and the maximum. That is a whole different experience. So those here, having seen the one last time for that 2 minutes, we'll get a different experience, and it comes from a different direction, and it will just not be the same. And I can't even predict how it will be different. I can only just go by the few experiences, because it takes a span of a lifetime to see eclipses.
Yeah. We were out in the backyard, my girlfriend and I, the other evening, and we live in the middle of Carbondale, a significant amount of light pollution already. But just looking up at the sky, you could see just, brilliant stars. And I told her, it is no wonder people 1,000, 2,000, even more years ago had such a fascination with the heavens, had maybe more of a religious and more faithful lifestyle, because when you look up at it, my goodness, what is up there and what can we explore? Is that sort of the opinion I guess you guys are under, right, Bob?
Oh, yeah. Although I do research on the sun, and that's what a lot of my work's about. I definitely can feel that connection as well, the human connection to it. It's spiritual for most people, seeing a total solar eclipse and seeing astronomy in general, seeing the stars and enjoying it.
So coming up this Saturday, we're going to get what they call an annual solar eclipse. Now, do these really happen every year? You just have to be in the right spot to see it?
Not always.
So what do they call it? Annual?
It's an annular.
I'm a dummy. I told you I'm out of my depth.
It's an annulus, which is a Latin word for ring. And being a ring happens when the moon is concentric within the sun. It gets nested inside. It's silhouetted. So
this gives us what they call the Ring of Fire, is what is spectacular to see.
Which is a misnomer, in my opinion.
Yeah.
I have a different opinion versus a total solar eclipse, because you need a filter to see it. What I find beautiful about it is when you get on the central line and you get that perfect concentric where the moon fits right inside the sun. So you're looking up at the sun like you would normally gaze at this disk, let's say, just askance, or in a cloud, you see this fat disk. Now you've got like a circle. It's a perfect circle. And that moment you're like, whoa, this is kind of weird. And they Ring of Fire being the Johnny Cash song and all that stuff. So it's popular. And
rolls right off the tongue.
There's no fire on the sun whatsoever. It's a hydrogen. It's a nuclear fusion reaction. So nothing's burning.
Nothing burning.
Yeah.
So the best viewing is in the west from, I believe, Oregon it starts, and then Texas is where it ends. But we're going to have some viewing opportunities right here in Southern Illinois through SIU, and it's completely free, open to the public, and I believe materials provided.
Yep.
What can people expect on Saturday, Bob?
So Saturday, we're opening up the stadium to the public. It's starting at 10 a.m., and 10 to 2 is the annular eclipse watch party. Now, it's a partial in our area, so people will see a partial or a crescent eclipse. It won't get dark, and you will need those solar viewers, the glasses or the viewers, or a special telescope. We have special telescopes in the stadium that allow people to look visually through an eyepiece directly at the sun and see some surface features. They're really nice telescopes, actually. Mike and I have been posting some pictures that we take with them online on Facebook these days. But the added part of being in the stadium, there's activities that are going to be there. It's a family-friendly event, and Mike and I are one of a few locations that are going to be streaming in what we see from across the country. We have, I believe, about 5 different streaming locations.
Oh, really?
Yeah, and then I'm one of the leads for the Dynamic Eclipse Broadcast Initiative, and we'll have several sites throughout Mexico, Canada, and the U.S. that are taking images as well. And so we're working with NASA Edge, which is a video podcast group for NASA, to take the imagery coming in and put it up on the big screen in the stadium. So it'll be a real treat for the people who come there that day.
So that's sort of almost the reverse of what we got during the big show last year, where our feed was going out around the country. Now other feeds coming back and on the Jumbotron in Saluki Stadium. Wow, that's cool.
Yeah, we're really looking forward to it, and Mike and I are going to be running all over the Southwest.
Yeah,
looking forward to some
before
clear
I came
weather.
out here, I spent like a week in a clock tower trying to plan out a route of potentially trying to dodge clouds and weather. Knowing all of Texas, I practically know every intersection road, local route where the Central Line intersects is a possibility, but it's better to know it as such. But I do have an idea where we may be going. But the setup that Bob was talking about was remarkable. I was blown away, as exhausted as I was arriving here. And when he said it, this mobile setup with this instant canopy where you pull it out, pulls out the table, he pulls out this the solar telescope. Then we set up a Starlink, and we're this mobile unit with this high definition video that we can provide. So if we can get this, if this happens, we get to the center line and we can send a feed up there in the internet and send it back down to the Jumbotron. This will be amazing, and I've never seen such a mobile unit before.
Well, yeah, when I think of professionals looking at the stars or the sun or what have you, I think of the big dome, almost the Adler Planetarium. The roof opens up, and you have this thing looks like a gun on a warship looking up. But how big is the equipment you're talking about?
Well, it's actually portable, and he was demonstrating to me like the tripod. So it was so lightweight because in the olden days it was so heavy. You needed a pickup truck to carry it around and move it and hoist it. But this could pick up. He was setting it up in like seconds. We were just putting this thing together, and we're like on with this high definition images of the sun in all its glory and hydrogen alpha light with prominence and stuff. And I'm blown away. and this could stream and go right on the internet and be a feed on TV. It's amazing. I've never seen anything like it. I've been around. I've been on scientific expeditions around the world. I've been sort of the foremost, and I see what's happening here at Southern Illinois University. I'm really taken aback, and I'm looking forward to working with it again today, and more and sharpening it. And we're a completely independent mobile unit with power inverter stuff. So we got that Jeep, and we're going out there, and we've got all the Southwest to go to as far as we can have gas to go and make it.
I almost get the vision of you guys like the old movie Twister with Helen Hunt and Bill Paxton. You're driving around in the pickup looking for the best spots.
Except we're doing the reverse.
Yeah.
We're trying to stay away from them, the tornadoes and the clear skies. But it is eclipse chasing, so instead of tornado chasing, there are same principles involved, same knowledge, same science, but we're doing the opposite.
Mm-hmm. And this guy on the American Monument text line, or woman, I really don't know, I just have a phone number. It maybe not be able to answer this yet, but what are the chances of cloud cover on Saturday?
Here?
Yeah, we'll go for here.
I haven't even looked it up for here.
What about Texas? Yeah.
I don't like to say things because I could jinx. This is where I get my spirituality from, let's say, and then jinxing. But it seems to be that it's going to be, a good chance for many to see it. Good. There are some problematic issues in the numerical models, but we're too far out. You got to go 48 hours, 24 hours, and even the night before. The night before watching and looking at satellite images in the infrared, because it's nighttime, and looking how the movements are, local things to get it clear. And it depends on what you're looking for. With an annular eclipse, for most of the general public, even partly, slight obscuration of the clouds, in some ways it can enhance. It's like a natural filter. But I don't want to talk about it because we have eye safety issues. So
that's one thing I wanted to talk about. During the last eclipse, we all got the warning of these glasses will expire at a certain date. They have a shelf life. Is that something folks have to worry about this go around?
They should read the back of the glasses. If they don't,
the box.
If they don't say anything about expiring, they probably do not expire. Actually, there were just there might have been just a few brands that had that printed on the back, and those, of course, you don't want to go against the manufacturer's recommendation on it. But in general, they don't expire. You just need to inspect them and make sure they look good still. But as Mike was saying,
we have the two reputable companies which manufacture them, Rainbow Symphony and American Paper Optics, and these are super high quality. These two U.S. companies, and they'll last forever. Those glasses, but they need to be preserved. Like, don't be throwing them around and scratching them like your records.
Don't put them on the
if it's something
dashboard
look like your old CD that you've been throwing around scratches, no, you can't use it. Any slight little scratch could potentially be a danger, but that's it. As long as you didn't ruin them, they do not expire. It doesn't have a shelf life like milk.
Dennis has a question that was familiar last go round too. Says, is it safe to view through a welding mask? And
it depends.
A lot depends.
Welder's glass number 14 is what I would recommend. 12 gets a little too bright, and then 16 is too dark. But 14 is the standard, and that's been the standard for way back. So if you can get a hold of that filter that slips into the mask, it's a square rectangular filter. Specialty shops have them. Welder's number 14 is perfectly safe.
Most welders will probably know what I'm talking about here, but we're talking about the old arc welding glass, not the newer. Some of the newer stuff isn't that dark, so you want to use the number 14, the older one.
Okay. We're joined in the studio by Bob Baer and Mike Kintrinakas, the, how do I say it? Annular solar eclipse. Doesn't happen every year. Now, we've been talking about what this is going to look like from the ground looking up. If you're up in space, what does a eclipse look like looking down? Is it anything noticeable?
The ISS has done photography of this, what looks like it's a black shadow, black circle going across the surface of cloud tops and the openings, and it's kind of muddy and it's a little brownish gray. It's hard to define it completely in its contour because the surface is irregular on the cloud tops and such, and cameras do injustice to it with the high dynamic range and showing that it's darker than it really actually is, because the darkness is totality, and yet it will show that darkness. So from space to see it, it's unusual that what's this black spot.
Yeah, you're looking at the shadow on the Earth from space often, because remember, we're in the shadow of the moon when we're seeing an eclipse. And so from space, you have to be in the right spot. You have to be in the shadow to see the sun eclipsed. Or if you're outside the shadow, you see that shadow projected on the Earth, is what Mike's talking about.
And here's got to almost see something like a James Bond, Dr. Evil sort of thing to be a big shadow on the Earth. Like
actually, Bob's big boy up there floating around, and there's a big black spot down there where he took off from. So in annular eclipse, the shadow of the moon doesn't touch the Earth. It doesn't make it. The moon is too far away. It's too small. It can't cover the sun. So it's somewhere up there high in the space, so many hundreds of miles away, where totality is happening. It doesn't end. So what happens is they invert these vortices, and you're now getting a partial eclipse, and we call that the antumbra, like an anti-shadow. But it still casts darkness in that the sun is being blocked, and each portion of the sun that gets blocked creates a darkness. It's that less. And how do you see that? You see that in terms of a darker blue sky. So if you're here on Saturday afternoon, you look outside right now, there's beautiful blue sky, but there's a slight whitish in it. That starts to go away. And when we go down with the annularity, we're going to get a deep blue where it's just before totality. That experience you get, you know it's coming. However, with an annular, you're waiting for that total. If you're so experienced, you're like, okay, it's not going to happen, but you enjoy it for what it is.
Still pretty
cool.
You know
what? And it still just encourages you to see the total.
This one comes from Mike on the American Monument text line. Sun rises in the east, sets in the west. Regular as clockwork, doesn't change. He'd like to know why some eclipses go east to west and some go west to east.
They all go from generally from the rotation from west to east, or from south to north, or north to south, but it's definitely a direction that's easterly, if we have to say it that way. So if we cut it in half, east-west, north-south, 180, make that all from northeast to southeast, it goes in that direction.
And but it's a globe, and it sort of alters our perception maybe of it a little bit.
Yes, it has to curve through that. Yes, the geometry, this three-dimensional geometry of the spheres, the shadow, and such. But it goes the other way only on the poles, because it's kind of funny. You have different directions. Like if you're in the North Pole, the only way you can go is south. So and vice versa at the bottom. So you have that kind of a turn because it's skipping up there. But generally across here, the spring and the fall have the north-south trajectories. That's why we have this angle. That's why in April we're coming up from the south from Mazatlan and going up to Maine, coming through Carbondale. And this one in October, we're going down sharply from Oregon all the way down. We're going to the Gulf of Mexico, right out of Corpus Christi down to South America. So it's going that way, it's sharper. But as we get to the summer months and the winter months, they start to go more generally across. Like east-west, generally. So you get that because of it's our axis of tilt. We change, and that's why we have our seasons, summer and winter, and then we have spring and fall. So that axis in different directions, but they're equal in angle.
Okay. Glad you're the scientist, not me. Joined in studio by Mike Kintrinakis and Bob Baer. Bob, you're sort of heading up the festivities at SIU this Saturday. What time does they start? What should folks expect? How long to stay?
Oh, gosh. So starting at 10 is when the gates open to the public there, 10 a.m. And I believe the local time for the start of the eclipse is 10:30. That's first contact, when you can first see the moon start to move in front of the sun. And then the public event, it actually goes on past 2 p.m., but we say 10 to 2 for the annular. And then 2 to 5, we have a football watch party in the stadium, so people can stick around and catch the Murray State game coming in on the big screen again.
All right, and completely free.
Completely free, yes.
Open to the public, and you'll provide the telescopes, you'll provide the viewing equipment. Just show up ready to learn and be amazed.
Exactly. It'll be down on the field. Bring your chairs and your lawn chairs and your blankets if you'd like, and just hang out for the day.
Sounds like a good day to me. And the weather for it looks pretty good too so far, but like you said, we'll be looking a little bit closer as the day comes. Mike Kintrinakis and Bob Baer, thanks so much for taking a few minutes out of your busy prep schedule and joining us in the studio.
Thank you.
Thank you, Rob.
Thank you.